All right, good afternoon everyone and welcome to grade 8 coding. It is the 27th of July and we're looking at until loops in a maze, right? So if we finish this, we are going to head into review. This is going to be a review week for us. Firstly, I would have reviewed according to my planning, but then it just so happened that this review week properly coincides with our informal assessment week, right? So while we have assessments happening, we can review the topics and take it from there. All right, cool. So I see you guys are here and ready to rumble. Okay, so just as a note, the entire last week I was under the impression that the 29th is Friday. And over the weekend, I came to realize that that is not the case. So the 29th is Wednesday, and that's the day that you will have your assessment, okay? So we're going to have class as per normal, right? There's no way that I can't administer a coding test like this across this platform. So what we're going to do is we're going to have class as per normal, review the topics that we would have reviewed, but on the website, the document containing the links to the puzzles that I want you to do will be made available. You can download that and then you can use that to do those puzzles and take screenshots and submit that to me. That would be awesome. And then once you're done, the next day or the 2 days thereafter, we'll just look at those specific puzzles during one of our lessons, okay? Or maybe two of our lessons. Right. So that's basically the way it's going to go, and I'll show you what I look for when I'm marking these puzzles. What do I want to see? What we don't want to see, and so on and so forth. Awesome. So let us get going. Before we do, YouTube peoples, you can find a link in the description box below that'll take you to our website if you want to register for the live lessons. Okay. Right. So from phones to cars to medicine, technology touches every part of our lives. If you can create technology, you can change the world. This is a quote by Susan, and I'm not sure how to pronounce that surname, but let's call it Wojcicki, or I don't know, Wojcicki, Wojcicki, I don't know. Anyway, the important thing to realize is that this Susan person is the CEO of YouTube. Okay, so if somebody who has such a high-end job within the tech field, especially for YouTube, when it comes to algorithms and things like that, YouTube is top-notch, right? The way that they do their ranking, the way that they do all of their stuff, it's very intricate. But it's impressive that they can manage it all because of just the amount of information that's on there. Okay. So when a person like that starts saying, you know what, whether it's creating a cell phone or creating a new car or developing medicine, such as they're trying to do now for this worldwide pandemic, technology touches every part of our life. So let's look at an example with the cars, right? There is a designer that's going to make it look pretty and an engineer that's going to make it work. But there will also be a coder somewhere within that mix, because somebody has to code the program that the designer is using to design the vehicle on, if he's not free drawing by hand. Somebody needed to design the program that the engineer is using to make his calculations on, or her calculations on. Somebody had to design a program to retain information so that the engineer and the designer had data to work from, information that they could process. The same with the medicine. Developing something as they are trying to do now to counter this massive pandemic that we're facing, there is collaboration happening between countries and between different departments and resources and things like that, people sharing resources. Somebody had to create, using computer code, the platform or the software or the program that they're using to collaborate with each other, to maintain data, to process that data, right? All of those things had to be created by someone who can code. That's what it boils down to. So if she says, if you can create technology, you can change the world, I hope that you realize that in the technology creation process of designers, engineers, and so on and so forth, there will almost always be a coder involved somewhere, even if it's in a minute bit, but there is almost always a coder involved somewhere. Whenever there is any type of computation that has to happen within a certain thing performing its function, a coder is needed. Software will be needed to do that, right? Okay, so let us jump into this. Conditionals, if-else logic statements that change the way the code is executed, okay? That's pretty straightforward. We've heard that countless times, right? The next one is saying conditional loops, they repeat, or they are repeats that execute while a condition is true or until a condition has been met. So it depends on whether it's a while loop or an until loop. Okay. So in today's lesson, we're going to look at until loops in a maze. So what that until loop means is it's going to keep repeating whatever you put inside it until you've reached the goal. And the goal is to get Mr. Zombie to the sunflower. Strangest zombie I've ever met, only eating sunflowers or heard about. Not that I've met this zombie, but anyway, you get the idea. Okay. So I'm going to jump onto our coding screen and just make sure that everyone has the link and we can get going, right? So this is what we're here for. We want to code. And this is where we pick up some speed until loops in a maze, right? Almost there, almost there. There we go. Beautiful. So I'm going to drop the link in the chat box for you to find. Oops, chat box, not address bar. There we go. And then I'm going to, as with every Monday, just talk through this quickly and then we can start coding. So what we have in front of us is what is known in computer language as a GUI, or a graphical user interface. GUI is the abbreviation. So what it is exactly that. It is a graphical interface that we use to interact with the software or the computer. So when the computer is talking to itself or they're talking to other computers, so two computers need to communicate. When I say to itself, I'm not talking about like a crazy person speaking to itself. I'm talking about the computer needs to have the ability to communicate to its internal devices, such as the hard drive and the RAM and the processors and so on and so forth. So all of that communication happens with binary code, strings of ones and zeros. Now, our brains aren't equipped to process that as quickly. So what we want is we want alphabet letters, and we want the numerical system that we're using, 0 to 9 numbering system, and we want to see colors and graphics and things like that, right? Because we are humans approaching the task with our human brains and our human eyes. So this is exactly what this is. You can see the graphics here, right? There are potatoes, and that looks like almost garlic heads or whatever. And you can see the path, and you can see all these things. Like there's a hint. It doesn't just say 100110, meaning hint. It shows you a small light bulb with a 1 there, okay? And this is what the graphical user interface is. It is what we use to interact with the computer or the software with, and it is in graphics because we are humans and we want to see the graphics. Okay, perfect. So that should be easy enough, and I hope that you understand that. Now, the next part that you need to know is, how do we navigate this graphical user interface? Well, that's pretty easy. You click on the lesson here and it'll take you back to the page where you can choose lessons. It's a section that I've created for this class under my personalcode.org account, and will allow you to go back to puzzle 1, right? Lesson 1, puzzle 1. And you can start from the beginning. So let's say you're new and you'd like to catch up. That's the way to go. And you can, I'll tell you now, Lesedi. You can also send me an email if you have any questions on those puzzles that you are doing, okay? Still come to the live lessons, right? Because you're going to pick up a lot by listening to us here, just speaking. That's going to help you even solve those things that previous lessons, okay? After I've done the interface, I'll quickly talk on binary code. Okay, so this is the puzzles that you find under that lesson. Green ones we've done, white ones we haven't done. The flags are extras, like bonus levels. This is the play area where we see the magic happen. Everything we code will act out here. Here we can see the instructions that tells us what to do and how to do it very often. It doesn't tell us why to do it. Okay, so that's why we are here in this lesson, so we can chat about it. Then we have here the toolbox with different blocks. Okay, and we'll discuss each block and its function or its functionality as we use them. To use them, we drag them onto the workspace and make sure they're connected. If they're disconnected like that, they won't work. If they're connected like that, they will work. And here we can see how many blocks we are still allowed to use. And we need to understand that these blocks aren't the actual code. They just represent the line and text-based coding, which looks like that. Okay. Awesome. So binary code, Lesedi, in the beginning, when people decided they wanted to know how much of a thing they had, they wanted a method of counting, a way of counting. So the first system was to draw a line for each thing. So that's when people started grouping things. You see it in prison movies, or if someone's trapped on an island or whatever, they draw 1, 2, 3, 4 lines, and then they dash it out with the 5th one, and that's a group of 5. So that was literally the first way that humans actually counted things, okay? Before that, there wasn't really a way to measure anything. Measure perhaps like, okay, 1 bucketful or a handful of an ingredient when you're making something, but I'm talking about now knowing, for example, how many things you have. So then after that, binary code was developed as a method of counting, which is more effective than that first system I spoke about, but it is less effective than the 0 to 9 numbering system that we use today. So binary code was chosen for computers. I really don't know why. I don't know why that was chosen, but what I can tell you is that each one of those strings represents an alphabet letter as an example. And there are many different combinations that can be made. So you can count to many different things. So what they do is they calculate the binary, and binaries are done in bits. So initially they used something that's known as, it's, to say that word now, okay, I'm going to say it. It's a diode, right? But what that is a small electronic component, and it has 2 states, either an on or an off. And there would physically be those things on a computer's motherboard, you could say, and different combinations of that would then have a different result. As in, if it's on, off, 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 on, off, off, it might represent a certain number. But if it's on, and the rest are all off, then it's going to represent another number. And each one of those numbers that it represents relates to a piece of information, such as a letter, as an example. So initially, that's how we used it, and 1 bit was okay to calculate all we needed. And then as of late, they realized that having just 8 isn't enough. So they combined 2 bits. So where previous binary was only a string of 8 digits that were either on or off, currently there's 16 digits that are on or off. And that's where 16-bit and 8-bit and those things come from. Okay. Right. So if you really want to know more about binary, there are awesome videos and stuff on YouTube that you can watch. But I don't really dive into it that deep because we don't use it. We don't program binary. We program in line and text, and the computer changes it to binary. So I don't really see a need for us to break our heads trying to explain that or understand that. Okay. So just type a yes in the chat box if you are ready, and we can carry on with this puzzle. So now that you're ready, tell me what to do here. What should I place on this workspace? This one's easy. Well, no, that's exactly why I don't study binary and things like that. I don't like to make things more difficult than they have to be. I try to keep them as simple as I possibly can. Okay. What do I do first? Move forward. Yes. Beautiful. Okay, but we only have one. While path ahead, they say. Okay. Okay, so I had 2 that said while path ahead, move forward. Awesome. So now we can use this one over and over and over again. Turn left. Where? After the move forward, after the repeat. Okay, we'll just stick it there. So just so that you know, okay, let's finish it and then we'll do that. Right, so we want all of this to happen until we've reached the sunflower. Okay, Nala said after a while there's a path ahead. Okay, good. So I just want to show you something here. We don't have to check for a path to the left, okay? Just think about how this conditional is working. Now this is on conditionals until loops, so we are looking at that loop. Specifically, that is an until loop there, right? A conditional loop. So let's say while there is a path ahead, do this. Well, what happens the moment when there isn't a path ahead anymore? It's going to use or execute the statement that comes directly after it, which is turn left, okay? So we can see here by how this map has been set up, at the moment there isn't a path anymore, turn left is the right option. It's the only option that we have. If we turn right, we're not going to get anywhere. So you can only, you don't need to put that turn left in a conditional as well. You can just place it and let it run. Okay, and then this one will tell the code to keep looping this sequence until the zombie is on the sunflower's position or at the sunflower's position, basically eating the sunflower. Okay. Awesome. Can we continue? Great. Okay, this one is a little bit more tricky. Help the zombie get to the sunflower. Go. You can tell me in the chat box how to do that. Yes, move forward is definitely correct. Move forward while path ahead. Yes. You only have one move forward. So we need to find a way to make that move forward happen again and again. Turn right. And repeat until it's sunflower. Okay. Right, so this is doing exactly what the previous one did, just the other way around. And what's awesome about this is the way we used to do it when we didn't have conditional loops, you would have had to come and count like, yes, it's exactly the same. In the previous one, we had to count, okay, 1, 2. And this one, you have to count 1, 2, 3. But using a conditional loop, you don't have to bother about that. So your chances of making a mistake are much less because now the computer is going to calculate it for you. Okay. Are you ready for the next one? Help the zombie get to the sunflower. Let's see if you can type the entire code out for me in the chat box in one message. Okay. The messages are coming in. Okay. So I hope you've noticed it is exactly the same thing. So 3 times in a row now we've had the same code. The only thing that differs is the left and the right. It's easy as that. So just so that some of you are certain, some of you missed this while path ahead, and some of you have this but not that one. Okay, so just check. You do need both, only one won't do the trick. You need to remember, if you place it like this last turn left is not in a repeat, so it's only going to execute once. If you want this to happen again, it must be in a repeat. Obviously cannot be in the same repeat as the move forward. Okay. Can I continue on to the next one? Challenge. Awesome. Woo, this is fun. Avoid the chompers and help the zombie get to the sunflower. This is an interesting one. But I'm sure I'm confident in your abilities. So let's see, what have you got for me? Type it in the chat box. Let's get this one cracked. Okay. So the first thing that you do need to know is, okay, sorry, I saw that I had a bit of a weak connection there for a second. The first thing that you need to know is you have to turn around. Like Lacetti just said, turn left ×2, because there is no move backwards block here. Otherwise, you could have just moved backwards and come down here, but now you have to turn around. Okay, wild path ahead, move forward. Like this. If you're happy with it, you tell me to click run and I'll do that. To move the turn left, put it under the loop. Turn right, you mean. Oh, is this what you want? Can I run this? Where do you want this turn left? There. Can't go under this because this is a repeat until goal. So it will, once it's reached the goal, there's nothing else left for it to do. Okay. You're almost there. Very close. But this time we're going to do it a little bit different. Try and do that. And think about what you can do with the turns to make the turns conditional. I don't know why you did this alone. Okay, so I'm going to give you some input here, right? So with this one, instead of saying while path ahead, because we're limited in blocks, we're going to move forward. So this is going to happen until that is there. But if there is a path to the left, we want to turn left. And if there's a path to the right, we want to turn right. And now we try this again. And there we go. If we do it the other way around, I hope you watch the path that he took now. The path ends up being different because the code is running sequentially. Okay. But well done. I like it that you stepped up, Lesedi, and you gave it a good try. You were almost there, right? In many of the other puzzles that we've done up until this point, you could either make this the conditional and just do the turns, or like now, you could have made this the non-conditional and the turns the conditional one. But for this puzzle, only this way would have worked. The reason is because there isn't a set place once a path finishes for you to turn, okay? In the previous one, all the turns were at the end of a pathway. In this one, that's not the case. In this one, it just shows you that there's a pathway, a turn here, which is halfway down this path, okay, as an example. So that would throw you off a little bit. The important thing to notice, though, is to check the sequence. You can see he turns there, but then the code tells him to turn again, so he turns the other way, okay? But the important part is to realize that everything stays within a sequence. And it follows sequentially. Okay. Right. Here we are on this one. Help the zombie get to the sunflower. This one I'll do, okay? So over here, you can see all the turns are going to be at the end of the pathway, right? So the turn is going to be sort of a constant within the loop. So I'm going to make the move forward the conditional and the turn a non-conditional. Okay. So in this one, as an example, we would not want to make the turns a conditional because there are other pathways that it can then take. You can see here. And if we have both here, we are over the numbers. It could work. He won't turn into any one of these little plants because the code is reading that there isn't a path there. But now we are using 7 blocks instead of the 5 that we were allocated to use. Okay, so the best solution for this one is the one we've been using since the beginning. It's the straightest, shortest, and least confusing way. Right, so this says, look carefully at the code below. What will happen after you click run? The zombie will pass the correct path and end up going back and forth forever. The zombie will make it to the sunflower. The zombie will turn right on the first path and go around in circles forever. Or I don't know. Okay. So now we need to read the code and see. While path ahead, move forward and then turn right. So this is going to move. It's not going to turn right because there's still a path ahead. Keep moving, keep moving. Again, not going to turn right because there is a path ahead. Keep moving. Over here, he's going to turn right. He's going to face up. Then he's going to move forward while there's a path ahead, which there isn't, so it's just going to turn right. Then it's going to come back down here. And this is going to be the pattern. The zombie will pass the correct path and end up going back and forth. Okay, so those of you that chose A, well done. I just quickly want to check something. I'm not sure. So we are a little bit ahead. Perhaps we can just look at the homework puzzle now. So I'm going to share it with you. Right. Pull all of the holes and remove all of the piles. So you've done these types of exercises before. Now we just need to practice it. So again here, we'll have to see exactly how we're going to do this. This is saying while there's a path ahead, move forward. What concerns me is that this path continues over there. And there is no, there's no if path to the right. So I think we're going to have to go old school here and count 1, 2, 3, 4, 5, 6. Down here, 1, 2, 3, 4, 5. Just see. Okay. This is going to say while there is a pile, remove 1. This is very interesting. I hope you're trying to crack it along with me, that I'm not the only one here. I am confused. You're very right. Luckily, it's homework, so I can also go and figure it out. I haven't done this one yet, so I'll just sit and play with it. And as you can see, this is literally the way I figure them out. I start moving code about, obviously, I take into account everything that I teach you to think, but what's catching me is because we're limited on the remove and the move, and there aren't any if conditional. So tomorrow we'll talk on this again, right? As you can see, that's what I feel like at the moment, and probably look like to you as well. Okay, so from tomorrow we're going to start with revision, as I said, and it'll be fun, right? It's good to review the concepts that we have done before. And then I want to thank you for being here. And if you've got any questions, or if you are a new student and you're going back to lesson 1 and you're doing those and you want to have any questions, or you'd like to share your code with me, you're welcome to do it to that email address. And you can find us on the social media channels, searching for that, Africa Team Geeks. Okay, have a great day. Thank you for being here. Invite your friends. Bye-bye.